So Pythagoras theorem and similar shapes.
A
Firstly,
squared plus B squared equals to C squared.
yes, a square plus b square is equals to c square. And where c is the hypotenuse, a and b, any one could be. One is the base and other is the perpendicular or adjacent and opposite. Hypotenuse is equals to base square plus perpendicular square. Basically, this is distance formula. Distance formula is derived from through Pythagoras theorem. So this being the longest side, name whatever b you want to and p, so it relates to each other. For example, we have few sides. If you have this 5, 3, and this is unknown, so we can write 5 squared is equals to 3 squared plus x square. 25 minus 9 is equals to x square. X square is equals to 16. Square root both sides, we get 4. So x is equals to 4. One could also say that show that this is a right angle triangle, or tell us if ABC is right angle or not. So this should not be there. So if we are given with values 13, 12, and 7, one question. Another question is, let's say this is D, E, and F, 13, 12, and 5. Both diagrams are not drawn to scale. So we have to see if they are right angled or not. So hypotenuse squared is equals to base square plus perpendicular square. If they are right angled, left hand side should be equal to right hand side. So that's 13 square is equals to 12 square plus 7 square. 169, 144, and 49. 144 plus 49 is 193. So 169 and 193. So not a right.
Pythagorean theorem. Pythagoras, I think that's how you say the name, only works on like right angle triangles. So
Yes.
this is just, yeah.
So for the next one, hypotenuse square is equals to base square plus perpendicular square. Hypotenuse is the longest side. 13 square is equals to 12 square plus 5 square. That is 169. This is 144 plus 25. And 144 plus 25 this time is 169. So yes, that's a right angle triangle. We'll come to similar shapes after we practice some of the questions. What are we going to learn is right angles, hypotenuse, and then this is slightly different topic for similar topics, similar triangles. Pythagoras theorem, you already know that a square plus b square equals c square. How to use the formula, you already know that. Finding the missing value. And let's work this out. So I can write x square is equals to 3 square plus 5 square for the first one. X being the longest side comes on one side. That is 9 plus 25. X square is equals to 34. X is equals to square root 34. Giving answer to one decimal place. So square root of 34 is 5.8 up to one decimal place. For the other triangle, do you have your calculator with you?
Yeah.
17 square equals 8 square plus x square. What do you get in the next diagram?
Right. Yeah. So it'd be, because that's the base. So it'd be
Could name it anything, base or perpendicular. Hypotenuse is clearly the longest side, which is opposite to 90 degree. Other sides
280,
could be switched.
289 minus 64. So it'd be 225. So it'd be 15.
Yeah,
Yeah.
15. checking for right angle triangle. So Pythagoras theorem, left hand side should be equal to right hand side for it to be a right angle triangle. Exercise 11.1, for all the questions in the exercise, give your final answer correct to three significant figures. So now there are two checks for full marks. One is the correct answer and other is it has to be to three significant figures. So find the length of the hypotenuse in each of the following. So we'll do one from each because they're having same nature. Let's try this C part with decimals.
6.73 square root, so that would be 2.59. Yeah.
Yes, up to three significant figures. Question number 2 says find the value of the unknown lengths in each of the following triangle. Let's do it for these two. A and D.
55 squared
Square root.
and square root. And
And
then the
now we still have to keep it three significant. It is for every question. So that would be 7.416198. So what is it up to three significant? 7.4.
I don't know what's wrong with this calculator right now.
Which one is it?
Sorry, I don't know what's wrong with the calculator right now.
Uh,
It's not
uh, I mean,
cooperating.
which machine is it? Can you show me? If it gives the wrong answer sometimes, you can go to memory reset. That would clear the garbage memory and you'll get the right answers. Do you
Okay.
find the button saying reset? For me, it is on top of digit 9. Shift 9 and then reset.
No, there's only clear on and enter, and
Yeah,
those are
clear all, yes. You'll get correct answers now.
okay.
And D part. Now, before solving this, can you just guess what the value would be without solving?
Maybe mm,
We're going to face a lot of this
points.
and we'll be able to memorize them, not specially, but just by solving some questions. We just did it two times. That was 3, 4, and 5. And we did one more question, which was 13, 12, and 5. One
So
is 25, 24. I'm forgetting it, what it was. And that's 7. So somehow, just by solving questions, when there are no decimals, this goes into our long-term memory. So when it is 12, 13, the third one should be 5. So this is already 13 and 5. This should be 12. Now we'll just solve and check. 169 minus 25 equals p square. 144 equals p square. P is equals to 12 meters. This is not a compulsion, but if we know it by heart, yes, we'll be able to save some time. Find the values of the unknown lengths in each of the following triangles. So number one,
Square root 17.63328.
square root. So just press that square root and get the answer in decimals. Because there are two checks in this question, correct answer and three significant figures.
It's not it's not working right. I don't know. I think
You
it's
should
something
have
with the like the maybe buttons or something, but it's not working.
2.3 square plus 1.6 square. It gives you 7.85, not 17.
7.85.
Yeah, 7.85.
So that'd be square rooted.
Square root
Also,
answer, and you're not getting that answer. Like the calculator isn't working after that stage.
yeah.
Okay, so I'll write it and you can choose it from the screen. Till now it is 2.80 because the next digit was 1. E part would be 12 squared minus 6 squared whole square root. So K is equal to,
K will equal to 180 square root.
this gives me 10.3923. What would it be till three significant figures?
It would be 10.4.
10.4 centimeters. How will we do this F part?
We'll just find the base. I mean, like the top of it, like the top, like the drawn on line,
We
and
are
like
given
the.
this. We are
Mhm.
given that they are same. This is isosceles. This is 9, 9, and 8. And I need to find the height.
So
Apply Pythagoras theorem.
it would be just through the middle still. So it would be just 9 and 8 would be the 9 would be the hypotenuse and 4 would be
4.
the perpendicular.
So 9
And
squared is equal to 4 squared plus h squared. 9 square minus 4 square whole square root is equals to h.
it'd be square root 65.
Square root 65. And in decimals, this is 8.06225, and up to three significant figures, this should be 8.06 centimeters. G part, solving for D.
Well, we'd first have to find like the base for it, and we'd have to do it through 8 and 6.
That's right. So let me name it X. So 8
Square root
square
28.
minus 6 square whole square root is equals to X.
So square root 28.
X is equals to square root 28. Now we can use it. D square is equals to X square plus 3 square. D square is unknown. X square is already 28 plus 9, 37 square root.
And that would be
6.0827 approximately equal to
6.08.
6.08 meters. H part. Without solving 3, 4, what should this be?
That should be 5.
That should be 5. Without solving 12, 5, this should be
13.
13. In exam, we will definitely show all the working. 3 squared plus 4 squared whole square root is 5. Let me say that was X. And on the other side, F squared is equal to 5 square plus 12 square. F is equals to 169. Square root both sides is equals to 13 meters. Question number 4 says use Pythagoras theorem to help you decide which of the following triangles are right angled. So even if our calculator is not working, which we can check is like without going into the square root. 10 square is 100, 8 square is 64, 6 square is 36. So 100 is equals to 100. Yes, that is right angle triangle.
And then
Use Pythagoras theorem to help you decide which of the following triangles are right angled. Now question B can't be solved. Third side is not given.
we would say unsolvable.
That would be a misprint.
Oh,
For now, that's a misprint because we should have this to solve it. Let's check for C.
it should equal to 196, but it equals to 169.
Yeah, we are still checking it, but we already knew that with 12 and 5, the side should have been 13
One, yeah.
for it to be right angle triangle. But yeah, so this is 169 on left hand side and 14 squared is 196. So that's a no. Another thing, maybe we'll face it shortly. It may ask that is the triangle acute angled or obtuse angled. Now, for instance, if this would have been 5, 12, and 13, we know this is right angled. So if it is more than 13, angle would be more than 90,
So it'd be obtuse.
obtuse. So whenever we have a hypotenuse side squared longer, it is obtuse. When it is shorter, it is acute. D part. Longest side squared should equal the shorter sides squared and added. 3.6 square plus 4.8 squared gives me exact 36. So that's a yes again. E part without solving.
Yes.
So that's a yes. A quick revision is 5, 4 and 3, 25, 24 and 7, 5, 12 and 13. These are the most common sites. Showing all the working in exam is compulsory. Now these are again Pythagoras theorem. It is just adding some statements to it, maybe to make the question interesting. The diagram shows a bookcase that has fallen against a wall. If the bookcase is 1.8 meters tall and now touches the wall point at a height of about 1.6 meters above the ground, calculate the distance of the foot of the bookcase from the wall. So basically, it is a simple triangle to us that is 1.85 and 1.6, and this should be x. So Pythagoras theorem 1.85 squared is equals to 1.6 squared plus x squared, and working 1.85 square minus 1.6 squared. I'm getting 0.8625 square root of answer. I'm getting 0.9287. 0.9287, so approximately equal to 0.9 to 2 decimal places, 93 meters. Clear?
Mhm.
So these statements are not making the question lengthy. This is just another way to represent the information. Now, what would this coordinate geometry do? We'll just use this to find the lengths. Find the distance between 2 points A and B. A and B are already there. So they are perfectly vertical. I can see from the graph that y value of A is 5. If I may write the coordinates, they are minus 3 comma 5. So from A to B, it is perfectly vertical. That is 7 and 5. Distance between 7 and 5 is 2. So we don't have to go through Pythagoras theorem or using the distance formula. Remember, x2 minus x1 whole squared plus y2 minus y1 whole squared and whole square root. Basically, that's Pythagoras theorem. Distance between AB point A, point B. So that's 2. AC again perfectly horizontal. It starts from minus 3. It ends at positive 3. So 3 and 3 is 6. Greater value subtracted the lesser value, you get 6 units. And BC, now we can apply Pythagoras theorem on 2 and 6. Question number 1. The size of the television screen is its longest diagonal. The diagram shows the length and breadth of the television set. Find the distance AB. So they're just adding stories
So just a
to
diagonal.
Pythagoras. So just the diagonal. So basically AB would be equal to square root of 48.6 squared plus 21.6 squared. Square root 48.6 squared plus 21.6 squared. It gives me 53.1838, approximately equal to 53.2 inches. What would be the answer for question 2? Find the length of the letter.
Square root 9.16.
This is square root 9.16, yes. So length square is equals to 3 square plus 0.4 square. Length square is equals to 9.16, square root both sides. Gives me 3.0265, which is approximately equal to 3.03 meters, two decimal places, or three significant figures. Question number 3 says, Sarah stands at a corner of rectangular field. If the field measures 180 by 210, how far would Sarah need to walk to reach the opposite corner in the straight line? So again, rectangular field, which is 210 by 180, and she needs to walk this path, X.
765, yeah. Square root.
276.58. Now, degree of accuracy is not specified in the question. Let's take it till three significant figures. So 277 meters. Question number 4. The diagram shows the side view of a shed. Calculate the height of the shed. So height of the shed is the full from top vertex to the bottom. So we already know this height is 2.4 and I need to find this upper section. In order to do that, 2 is already given for the hypotenuse and I need this. What could this be?
It would be half of 3.2.
Half of 3.2, 1.6. So this x is 2 squared is equals to x squared plus 1.6 squared. X is equals to square root 2 square minus 1.6 squared. And I'm getting exactly 1.2 meters. So the height should be 1.2 plus 2.4 is 3.6 meters. Question number 5. The diagram shows a bridge that can be lifted to allow ship to pass below. What is the distance AB when the bridge is lifted to the position as shown in the diagram? Note that the bridge divides exactly in half when it lifts open. The distance AB, can you do that? I'm getting 0.841324, approximately equal to 0.84 meters. Let me know once you're done. Then we can discuss the working.
How did you get this one? I know it's in half. It's going to be 43 and 43 on both sides for the longer line.
No, that's the diagonal. See, this was 86. When it opens and up in half, this is 43, which is actually making this now. So this is 43 and this is 43, which raises up. So once we know this, we know the height is 6 meters. We can find this. The section is going to be, let me call it X. And this would be equal on both sides. So X is equals to 43 squared minus 6 squared whole square root. Any objection?
No.
So the distance AB could be 86 minus 2x. 86 minus 2 into, and we're using calculator for x. Square root of 43 squared minus 6 squared gives me 7 square root 37. Avoiding all the decimals, I'm getting this. And now 86 minus 2 into 7 square root 37. I get 0.84132 So if the degree of accuracy would have been specified, this is meters. Clear?
Yes. In an exam, it will always be specified, right?
Yes, yes, always. On the first page, it mentions that give all answers, all non-exact answers, up to 3 significant figures, and in case of degrees, to 1 decimal place. If angle is asked. Question 6 is, find the distance between points A and B with coordinates. So we need to use the distance formula. And if we realize that they are perfectly vertical or horizontal, we can straight away just answer it, which is not so in this case. Question 6, A part, coordinates of A are 3, 2, B are 5, 7. So distance AB is x2 minus x1 whole squared plus y2 minus y1 whole squared whole square root. 5 minus 3 and 7 minus 2. This is 2 square, 5 square, and we just keep on simplifying. That is 4 and 25. This is square root 29. So square root 29, if asked in decimals, would be 5.39. It is rounded up to 2 decimal places or 3 significant figures. Okay, if we just avoid this and find the distance between, let's say part P is 2, 3 and Q is 2, 9. What is the distance between PQ?
Can I see the formula again? Thank you. Square root 6?
That's only 6.
Only 6?
Yep.
Well, it would be
Imagine
0.
you should have done this without formula, but just to show you, I'll just solve it and show you how to do without formula. This was x2 minus x1 whole squared plus y2 minus y1 whole squared is whole square root. So second x is 2, first x is 2. So 2 minus 2 whole squared plus second y is 9 and this is 3. 9 minus 3 whole square root. Now this is 0 plus 6 square. If I just write 6 square root, I can get rid of that and that is 6. Even if you choose to solve it, 36 square root, you again end at 6. Now just imagine you were given 2 comma 3. So if this is x1, 2, let this be 2 comma 3 and the other one is 2, 9. X is not changing. So when x is not changing, this is perfectly vertical and from 3 to 9, that's a 6. So PQ without using this distance formula could have been 9 minus 3, 6 units. Another example, let's say coordinates of x, or let me avoid x and y. W are 4 comma 5 and coordinates of t are minus 7 comma 5. So what would be the distance WT?
So, because the y doesn't change.
Yep,
11?
11. So y is not changing. It is greater value minus the lesser value. So 11 units. Another way to do it quickly. We already know what the formula is. Let me write it once. We know the formula is x2 minus x1 whole squared plus y2 minus y1 whole squared whole square root. And when I do so, keep that in mind. We are not going to skip any sort of working in exam. So this is our class practice. This is our home practice. And we should know how to solve questions quickly. May I say x2 minus x1 actually gives me change in x, which we just did in this last question. X2 minus x1 was giving me the change in x. The change is of 11 units. And so was this giving me change in y, y2 minus y1. So basically, if I just look at this B part, may I say change in x is 1. So 1 squared and change in y is 3. What we would have done when we substitute it in formula, we're doing it mentally. X2 minus x1. I'm looking at that 6 and 5. 6 minus 5 is 1. changes 1 and 8 and 11 changes 3. So 3 square is 9 plus 1, 10. This is square root 10. Distance AB for B part is square root 10. Makes it 3.16. Next one, what is the change in X in C part?
It is 7.
Very good. 7 square and change in Y,
It is also 7.
7. So square root 7 square plus 7 square gives me 7 square root 2, which in decimals is 9.899. So up to 3 significant figure, that would be 9.90 units. D part. Change in X is,
D,
yeah,
it would be 9.
it would be 5,
Oh, because
a
when
negative.
we, yeah,
So 5 squared and change in Y is,
it would be 8.
no,
9 would be 9.
9. So 5 squared plus 9 squared whole square root is square root 106. Approximately equals 10.3. 3 significant figures. Let's move on to understanding similar triangles. All of the following are true for similar triangles. Corresponding angles are equal, first thing. So if we are to name them with the initials, we call this property A, and A, triple A. That means angle, angle, and angle. These two definitely correspond to each other. The first angle on the left bottom with the first on left. Second on right bottom with the second on right. Third on top with third on top. But even if we twist these triangles, if I say this is 50, 60, and 70, also making a sum of 180. On the other side, I make it twisted, turned, and I say that this is now 60, that is 50, and this is 70. 70 was on left, now it is on right. But anyone would see and say that angles in the first triangle are 50, 60, and 70, and angles in the second triangle are 50, 60, and 70. So if the angles are same in both of them, we can say yes, they are similar triangles. So first property is angle, angle, angle. Have you done this topic before?
No.
Okay.
I've done Pythagoras theorem, but I've not done like the similar triangles.
Another example to understand similarity, because we'll be doing congruency too at a later stage. If you just take a picture of a window, that would be exactly the same way but smaller in size. In your phone, let's say the window in reality looks like this, 4 feet high and 2 feet wide. And when you take a picture in your phone, let's say that is 4 inches by 2 inches. So by whatever ratio the length is reducing, the width is reducing with the same ratio. But notice that in the original window, the angle was 90 degrees. It is not reducing, it is still 90. Only the size is reducing, angles are same. So basically same angles show that images are similar. For example, you take a picture of a house and that is somehow like this. So whatever it is in reality, all the lengths are reduced in size but all the angles are same. So first property is angle, angle, and angle, because we are talking about triangles and there are three angles. Second property, it says internal ratio of sides are same for both triangles. This is just an example. He's done it with two sides. All the three sides will give the same answer. Let's say AB is similar to DE. And if AB over BC is written, it is equal on the other side with DE and EF. Let me do it this way. May I say this side is similar to this
Yes.
because the triangles are not twisted. The second side is similar to this,
Yes.
and the third side is similar to the third side. So I could say AB divided by DE. Notice that both of the sides are coming from two different triangles. AB divided by DE is equals to BC divided by EF equals to AC divided by DF. And notice that every side of the first triangle is written in the numerator, and every side of the second triangle is written in the denominator. We could change it, but we choose one triangle and we keep it on top at all times. You would have seen toy cars. For example, we talk about a BMW in reality and a toy car which is exactly similar to that. So if I would say that the length of the door is 1 meter in real, and in a toy car it is 10 centimeters. If I say that, and I give you the height of the real car and I say that this is 1.6 meters, what would it be in the toy car?
It would be 16.
It would be 16. So that was 100 by 10 is equals to 160 by x, and that is 16 centimeters. So this is similarity. Another example, you would have seen a prototype of a building which is to be constructed, and you see a model. So that's smaller in size, but the ratios would be proportionate. You
Like the
can pretty much
blueprint.
see. Blueprint is on paper. I'm talking about a 3D model.
Oh, it's a
And yes,
okay.
both are true. Blueprint, both are true. For example, if we were talking about this car, we talked about the length and height. I can also go for the width, all three dimensions. But for similar figures, yes, they stay the same. Third case ratio, which we've already discussed, ratio of corresponding sides are equal, which we just did. Ratio of corresponding sides are equal. If the length of the door is 10 times, everything would be 10 times. I can measure the distance of tire on the toy car and tell the distance of tire in the real car without measuring, because I now know that it is 1:10. Worked example. Explain why the two triangles shown in the diagram are similar and work out x. Firstly, we have to show why they are similar. We just did one property, that was angle, angle, and angle. If I may look at the smaller triangle appearing smaller, that is A, B, and C, I do have two angles. How can I find the third one?
It's gonna be on the other triangle, so 45.
Yeah,
You can
maybe,
add them
but
together.
first we need to know that they are similar.
So you need to add them together and then subtract it by 180.
Yes. So 180 minus 108 and minus 27. Obviously, if we are going to show that they're similar, it has to be 45. But I am going through my working and it gives me 45. So this is 45 and on the other side 45, 108 and this should be 27. So explain why the two triangles are similar. We'll say that all three angles are same
Mhm.
and work out x and y. Now, if I
Well,
may hide this working, now we need to understand the similar sides. I'm going for x first. If I write x, what is the similar side to x?
it's going to be D to F, so it's going to be 9.
9 is equals to, now I need a known pair. I cannot choose 8 because y is
Uh,
the corresponding side,
6 and 18.
6 and 18. And at all times, C, A, B, C is in numerator. So already this is 6 one times and 6 three times. I can see this is 1:3. So x should be 3 times lesser, equals to 9 by 3 is equals to 3. X is 3 meters. Now y should be 3 times more. That is 8, 3 times 24. But definitely during exam, we have to show all the working. So I'm going to write it again. 6 by 18 is equals to 8 by y. Cross multiply 8 into 18 by 6. 6 one time, 6 three time, 8 three times is 24 meters. Okay, the diagram shows a tent that has been attached to ground using ropes A, B. Slowing down a bit till we read the information. A, B rope and C, D. C, D on the other side. So this section is that tent. A, B and C, D are the ropes. A, B, F. A, B, F and A, B, F is this. And D, C, F on the other side are straight lines. Find the height of the tent. Now let me just hide this. I need to know the height of the tent, which is FE. Can you point out two similar triangles?
Uh, CHD and BGA.
CHD and BGA.
GA.
Now note the difference. What you're saying are congruent triangles. And we are doing similar. I'm coming
Mm.
back to the example. We take a picture with our phone, and in reality, the window is a very large size. But when we see it on our phone, that would be in inches. Compared to congruent, what is congruent? You
They're
buy two cars. The two cars are congruent to each other, and you buy a toy car. The real car is similar to the toy car. So they may be different in size, but when they are exactly same, 100% same size, same angle, everything same, they are congruent. Let's say model houses. You passing through a street and you see three houses constructed exactly the same way. Same size, same doors, everything same. So they are congruent. But when you buy a toy of the similar house, but that's smaller in size, that is similar. The real thing could actually be smaller in size too. Whatever we've discussed, the imagination or the toy is smaller. For example, if we talk about computer processor, so in reality, that is a very small size. But when we discuss about the model, it may be larger displayed on a table to discuss the specifications. So if I say 3, 4, and 5, and when I compare it to this 3, 4, and 5, both of these are congruent. And
Exactly.
when I write 6, 8, and 10, these are similar. Can you see that every length is twice the other?
Mm-hmm. Four
So they are
times two and a half.
similar. And when they are exactly the same length, they are congruent. So if we look at this question again, this triangle in green would be similar to this triangle in blue.
Oh, so it's
So
inside
if
similar
I
to.
may write for myself, may I write ABG is similar to AFE. While I'm writing this, I'm being careful that ABG, A corresponds to A in larger because AB corresponds to AF. So first two should correspond to the first two in the other. And how am I able to say, or why am I confident that they are similar? Because I can see that BAG without finding is equal to BAE, the angle,
Mm-hmm.
without finding. And AGB, I know that this is perpendicular. And AEF is perpendicular. I know only these two angles. And I'm confident that subtracting these two, let me say this is A and this is B, subtracting A and B would give me C. So in the other triangle, they're also going to give me C. That won't be different. Getting it?
Mm-hmm.
So erasing all this, now I can say AB is similar to AF and BG is similar to FE. I needed the height of the tent. So if I write FE and it is similar to which side?
It's similar to BG.
BG. On the other side, because I started with the greater length, so I'm going to write AF first and then
A.
AB. Now what are we going to do? Just fill in the values. FE is unknown, BG is 0.9, AF is 1.2 plus 1.8, that is 3, and AB is 1.2. So FE equals 3 by 1.2 times 9. That gives me 22.5.
So the height is 22.5.
22.5 meters, yes. Clear?
Yes.
Let's discuss one more example. For example, someone asks you to find the height of this building. And maybe we couldn't because we lack the necessary equipment. But what we could do is, for example, we place a small object here and I'm placing my eye right there and I'm looking here and this passes over the building. So I readjust myself and I place my eye here and I see that this now passes just over the tip. Readjusting, and my hand is shaking. Let's say this passes exactly over the tip. So now what I can do is, they ask me about the height. Height is unknown. Now, for us to communicate, I'm labeling it A, B, C, D, E. I would know the height of BE because I placed that object. I can measure the distance AE easily because that's on ground. No?
Yes.
Yes. I can measure the distance AD again because where I stand at A, from A to the bottom to the foot of the building. So I have these two. I can now find the height. How? CD divided by BE is equals to AD divided by AE. Notice if the pairs are correct.
Yes.
So we needed this, that is unknown. AD is known. We could measure it easily because that's on ground. AE again and BE again. So when we have these three values or we measured these three, we could find CD easily. And let's say I change this building over the mountain. So we could do the same process in finding the height of the mountain.
Anything.
Anything using similar triangles. Obviously, there would be errors and we might have tolerance level for our data. Exercise 11.3, for each of the following, decide whether or not the triangles are similar in each shape. For the first one, I'm finding the third angle, 180 minus 63 minus 59. I'm getting 58.
So
So
yeah,
180 minus 63 minus 58, I'm getting 59.
so it's similar.
Yes. It says in each decision should be explained fully. So we would say all three angles are same.
AAA angles are all
Angle,
the same.
angle are same. Correct. What about B? Is it similar?
Yes, because the measurements, like for example, 5 to 10 is like times 2, 3 to
Times 2.
6 is
So we can say 4
the
by
ratio.
8, 3 by 6, and 5 by 10. We can say that they are 1:2. Or we can give the statement all sides are in similar ratio. C part.
Oh,
I'm getting 67.
so no, not
And
all.
E1. So when it is a no, we say that angles are not equal. What about D?
D?
Yeah. Doctor, D part.
No, because normally it's supposed to be times 3, so the ratio is 1/3, but for 7 to 22, it doesn't work.
Very good. So ratios of sides are not equal. E part, 180 minus 49 minus 54. I'm getting 77. So that's a yes. All angles are same. Last part, F.
No.
That's a yes.
Oh, sorry. I was aligning them with the wrong numbers.
It's twisted. It would be twisted in exam. So 6 3 times is 18. 7 3 times is 21. And 9 3 times is 27. So we'll say they are in similar ratio. And notice that all the first triangle is with the longer sides, but he's drawn it smaller in size. They are always not drawn to scale.
It will or it will not be reversed. I mean, like flipped in the exam.
Most probably flipped.
Okay.
Like there's a very greater chance that it would be flipped. Okay, now when you look at this G part, we're talking about 7 meter. Are you just comparing all three with all three?
No, you can compare. Yeah, you have to see if they're all the same.
So Look at this thinking process. If I just look at the smallest side, which is 7, and look at the smallest side on the other end, and nothing else. So I'll see 44 by 7, and then I look at the longest side, which is 10, and 60 on the other side. I'll see if this is so. Longest with longest, shortest with shortest makes it quick to figure out. Or else what we would be doing, we are checking 7 with each of the three, then 8 with 3, then 10 with 3 sides. And we are left with the middle side, which is 48 and 8. And clearly this is 6, and 7 6 times is 42, is not 6.
So it's not
It's
similar.
not similar because the ratios are not same. This is 6.28 something, so not similar. No, because ratios are not same. Now look at H part. What is the smallest side you see?
It's going to be 4.1 and 9.6.
Smallest.
Oh, 3.2 and 9.6.
3.2 and 9.6. So we divide them. 9.6 divided by 3.2, I'm getting a 3. So I just check that. Now I am checking the longest side.
Which is 5.4 and 12.3.
So 12.3 by 5.4. So there you go. I'm getting 2.27. So that's a no again. Makes the process a bit faster. Now I part. We'll be using some basic knowledge of angles when we studied polygons and angles. Give it a try. See if these two are similar or not.
Well, I know that for C, it's vertically opposite. So it's going to be the same for those.
Okay. So this first is equal to this first. What next?
And then, oh, because it's alternate, it can be a Z shape. So it's going to be A and
Very
D arrows.
A and D.
And the same for B and E.
Same for B and E.
So yes, it is
So yes,
similar.
I just named it for myself butterfly shape. It is always similar because of the same reasons you just pointed out. And before you solve this pyramid shape, this is also always similar. There's only one condition we have to make sure this should be given that they are parallel. This should be given that they are parallel. So whenever you see such triangle with parallel lines, yes, they are always similar. Whenever you see this butterfly with parallel lines, they are always similar with the same reasons you just pointed out. So if we look at the smaller and larger triangle on right hand side, this angle in both the triangles small and large is equal. Then this angle is corresponding to this angle. And the third one is this, equal to this, named as corresponding angles. So all three angles are same, and yes, triangle ABE is similar. This is, yes, similar. Question number 2 says the pair of triangle and the question are similar. Calculate the unknown letter. Okay, now this time this is already given that they're similar. So we don't have to worry. We can just use the triangle, which is x by 8 is equals to 9 by 6. Does it make sense?
Yes.
And again, this first diagram was not twisted. It won't be the case all times. So x is equals to 9 by 6 into 8. 9 divided by 6 into 8 gives me 12. Try this D part. And obviously for these questions, only two sides are given. We can still figure out. But you need to know, is 3 with A or 23?
It's going to be with 8. I mean, A. 3 is
Your
with
answer is
8.
correct, but how are you so sure? Like if I just write 28 by 3 is equals to a by 7, because that's an unknown. A could have been more than 23 if I'm relating it to 7. A could have been more than 28 if I'm relating it with 7. Your answer is correct. How are we sure about that? You see that 3 is opposite to this single marked angle and A is opposite to that. So that's another hint. A by 3 is equals to 28 by 7. So A is equals to 4 into 3 equals 12. I'll share this remaining exercise with you from question 2 to this 8 along
Okay.
with the answers. Anything you would like to ask?
No.
Now, understanding similar shapes. In the previous section, we worked with the triangles and shape was similar if we had similar ratio and same angles. Now, worked example. Ahmed has two rectangle flags, one measure 1000 by 500. 1000 by 500. And the other measures 500 by 350. So if I can just check, this is 1000 by 500 and the new one is 500 by 350. Without any working, I can clearly see that the ratios are not same. This is half of that, but this is not half. If it would have been 250, then they were similar. So you see a relation between 1000 and this 500, that is twice.
For the answer that we give for this question, do we have to like also find the ratio for 500 and 350, or can we just say it's not half?
When we say this, we do have to show some numerical working.
Mhm.
So if I'm just giving the statement that the sides are not in same ratio, I would have to show the working. So I'll say 1000 by 500 is 2, but on the other side, 500 by 350 is not equals to 2.
Oh, okay. So that was what I was saying. So we don't have to say, for example, for this one, it said 1.43. We don't have to write that. We can just write it's not 2.
That's right.
What the
Just
math?
a sec.
Okay.
Mm, Just a second. I'll be back. You just have a look at work example 8. Does it say? Given that the two shapes and diagram are mathematically similar, we know that they are similar. So we may have different ways. I can see that these two should be similar and these two should be similar because somehow we understand that those two are the shorter sides and the vertical ones are the longer sides both. So 20 by 8 should be equal to x by 12. And then we cross multiply. So 20 into 12 by 8 is equals to x. 20 into 12 is 240 by 8 is 30.
Yes. X equals to 30.
X equals to 30. And when we do so, just coming back to this, for example, when we were saying that we can give our statement, assume that our statement is incorrect. So we lose all of our marks. But if we've written something on page and then a statement, we can expect something out of it. We
Like
won't lose all of the marks. So sometimes the question is easy. You're able to solve it mentally and just write the answer. But working will always help.
for this one, we just have to show like the proportions. That's it, right?
Yeah, ratios,
Yeah, ratio.
proportion, yes. 11.4, establish whether each pair of shapes is similar or not. Show your working. Now, this is between your teacher, that's me, and the question.
No.
So, what we can do is we can always work out with each other and understand what your answering style is. But when the examiner says, show your working, he will never let it go if the working is absent. He has marks for that. So now select your side, 5, 2, and 6, 4.
Mm-hmm. So it'd be 4 and 2 equals to 4 over 2 equals to 2, but 6
4
over
over 2
5 6 over 5 does not equal to 2.
is not equal to 2, and that is 1.2. So not similar. Now on the other side, B part,
It's similar because all the angles are the same, all 90,
first thing, yes.
and also all the sides are the same. I mean, not the same. I don't.
Now see, you do understand, but you're lacking those words.
Yeah.
An examiner won't give you that chance to explain. Again, when I come back at question 1 to understand 1A and 1B, difference between them, all the angles are same in question A, so are in question B. In question A, ratio is not equal. In question B, ratio is equal. How?
Because
Let me
all of
say
them,
this side is Y and this side is X. So I'll write Y over X is equals to, what do you think the other side would be?
it's
What is
also
this side? Y, and this side?
X.
X. So ratios are same because it is a square.
So all the angles are the same, ratio is the same, and the angles.
Angle and ratio. That's it. Now, when we look at question number C, I can see there are 4 angles, but they're not given. When they're not given, he's not questioning about them. So they're out of the context. We look at the given data. So we can see 5 is similar to which side?
4.
4.
4.
Now I need to see 5 by 4 is 1.25. And what should I check next?
3, 4 and 3.
4 and 3. Because I kept 5 in numerator, I'll keep 4 in numerator again. And 4 by 3 is giving me 1.33 recurring.
So not similar.
0.3. So they are not similar. These were similar. Look at D part. Now let's do it other way around. Uh, this 60 divided by what?
80.
80. So this 60 by 80, I'm using my calculator meanwhile, is 3 by 4, which is 0.75. On the other side, 45 by
60.
60. Because we selected longer side divided by longer side and shorter by shorter, and I'm getting exactly 0.75. So angles are same. Let me, it just crashed. Display that again. So this was longer side and shorter side. 80 by 60 we got 0.75 and 60 by 45 we got 0.75. So that's a yes. They are similar. Work out this E part on your own completely and let me know the answer.
The ratios are the same.
Very good.
Um, 6 divided by 9 and 12 divided by 8 is 0.
Okay.
Not
Okay.
0.6.
Longer side by longer side and shorter side by shorter side. So ratios are same and we can see these 90 angles are same. So it is similar. What about F part? How will we do that?
Can I quickly get water?
Sure.
Okay, sorry.
Okay. F part.
It's not the same because the angles are not the same.
Very good. And let me draw another one. So we're comparing this A with B and I mark this side and I give this angle as 80. Now what will we say?
It's similar because all the angles are the same with each other, I think. I mean,
Angles are same
uh-huh.
and so are in the rectangle, but rectangles may not be similar. Now we have to write something about side as well. Now assume that I write y over here. So may I write y over here too? Because this is given that these two sides are equal. So if I write x here, I may write x on the other side. So this by this, left side by left side and right side by right side, the ratio is still same. If this would have been the question, we would say that they are similar. So currently for F part, no, because angles are different. Very good. Question number 2. In each part of this question, the two shapes are mathematically similar. So it's already given that they are similar and we'll be solving for the missing sides. They are mathematically similar to one another. Calculate the unknown length in each side. First one, can you dictate me?
9. X would be 9 because 15 divided by 5 is 3. And we just times the ratio by the other 3 down.
Very good, very good. This is 9. So may I write the working like this? X divided by 3 is
Equals.
equal to 15 divided by 5.
Mhm.
So now we go on the other side, multiply 3 there. X is equals to 15 into 3 by 5. 5 1 times, 5 3 times, and 3 times is 9. And yes, the way you did, like 15 by 5 first, you knew it is 3 times. And then another step, x is equals to 3 into 3 is equals to 9. Both workings are acceptable. B part. Now, somehow in question 1, we were getting the exact number. That was 3. 3
Mhm.
times. Now, in question B, there are decimals. So it would be better that we write it this way. Y divided by
22.
very good. And on the other side,
7 divided by 11.
7 by 11. So y is equals to 7 by 11 into 22. 1, 2, and y is equals to 14. C part.
Well, we can do 7.28 divided by 3.62 equals to P over 1.64.
1.64. Very good. So P is equals, use your calculator. Let me know the answer. Has that issue resolved? We were having some issue with the calculator last time.
Yeah, my brother was able
Okay.
to look into it. He was able to fix it.
Very good.
Well, I got like a really long like decimal number, but if I round it up, it will equal to 3.3.
Very good. So if we have to write it up to 2 decimal places because all the other values are at up to 2 decimal. So we'll write 3.30 to make it 2 decimal place. D part.
Well, it's
And when you do all the questions correct in class, do the same in test.
okay. For this one, it's going to be 10.3 over
10.3.
8.4 equals to y over 11.6. Oh, no, no, no,
10.3.
no, 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 no. It's 11 .6. No, no, no. Yes. Wait.
Take your time.
Y over 10.3 equals to 11.6 over 8.4.
Over 8.4. Because that's a diagonal line. Diagonal over diagonal and straight over straight. And y over 10.3 is, and one more change. One more change. This fraction should be other way around.
Oh, so it's gonna be 10.3
Yeah,
over y.
because we chose this side first, y over 10.3. Then we choose this side again. So 8.4 over 11.6.
Okay.
10.3 times 8.4 divided by 11.6
I got
is
7.5.
7.458. I'm rounding it to 2 decimal and I get 7.46. Do we get the same answer? Centimeters. E part. Now be a little careful because you have 4 sides in left figure and 3 sides on the figure on right hand side. Which one to use with which?
Well, the x is going to be used with 40, but
Oh.
the x is going to be used with 40,
Do you
and
think the shape is twisted? or it is presented in the same way?
I think it's same way.
Same way. Can you solve for x without working? Without working, just by looking at the diagram. Let me draw those arrows. Are these two sides similar? Secondly, are these two similar? Thirdly, are these two similar? And fourth, the missing side, I'm not drawing that arrow. So if this is the case, I'm just looking at the diagram and I find out that these two are same length.
So it must be 50 and 50.
Yes. So x is equals to 50. Now, this is what I thought. But where is my working? That's not on page. That was verbal. That was mental. So we have to show something on page. Now this comes out to be 50. Now let's see what our working has to do. Now left side is x. On right side is 40.
Mm-hmm.
And now left side is 50. On right side is 40.
Mm-hmm.
So when we do the working, x is equals to 50. We just wrote that. But now above that, one step is the working.
Also the y. So for the y, would it be also 50 and 40 equals to y over 20?
50 by 40 is equals to,
Y over 20? No,
consider that
20
again,
over y. 20 over y.
20 over y. So we cross multiply 20 into 40 by 50.
So 16.
16. F part. So where do I draw this arrow of for 8?
8 and 10.
8 to 10. And x with
28.
28 and y with
21.
21. Now I'm telling you one more thing. Whenever we write this, if we write the unknown first, we'll have lesser number of steps. Come back to E part again. We wrote y in the denominator, so we had to cross multiply. Now see if I write x first, which is unknown. X divided by 28, which we've already decided. On the other side, now I'll choose some known pair, which is 8 and 10. So what I have to do is I have to take this 28 only on the other side and no movement with the x. So 8 by 10 into 28 is 22.4. Getting the point?
It's basically a lot easier to do it this way.
Yeah. Would avoid careless mistake. Now, let us call these pairing x by 28 and 8 by 10. Dictate me the pairing for y.
Y over 21
Y over
equals
21
equals to 8 over 10.
is equals to 8 over 10. So y is equals to 8 by 10 into 21. 8 divided by 10 into 21 is 16.8. Now consider one more thing. When we already know that x is 22.4, would we do this y over 21 is equals to 22.4 over 28?
Yes, you can.
Let's see if we get the same answer. 22.4 over 28 into 21. 22.4 divided by 28 into 21. I'm getting exact 16.8.
But without the decimals, it would be a lot simpler.
That's right. One thing. Maybe we would have all the answers without decimals, just like in question number 1A and in 1B. But what I'm going to highlight is, for example, someone did this. If their x was incorrect, what will happen to their y?
It'll also be incorrect.
Also be incorrect. Now, he will be graded those marks. Why? It is known as ECF. ECF. ECF is known as error carried forward. There was an error in calculation for x, but his working is purely correct. So he will be graded for y, but not for x. X is wrong. And whenever we get chance that we may use the data given by the examiner, which was 8 and 10, we should do that.
Just so
G
we
part.
can still get the marks for one of them.
Yeah, if X is wrong, he'll get marks for one of them. But if we use the data, we have the probability to get both marks. Because for sure 8 and 10 are correct. G part.
Well, it's y and 25. And it's
Very
also
good.
15 and x and 24 and 12. So we can, like you
Yes,
said,
yes, very good.
uh, so for that one, it would be
If I just look at these
4.
two, if I just look at these two, can I think what Y would be?
Yes, so it'd be 1 over 2.
It, it would be half of, yes, it would be half. So that would be 12.5. So whenever the question is easy, it is very tempting to avoid the working. And I can guess what X is, but I do have to write it in order to fulfill this demand. The mathematically similar, yeah, this show your working. So you have marks for them whenever we call it fulfilling the demand of the question. And if the examiner says we had some questions which we have long answers, like this one, C part, 1C, where we found P. But if the examiner will say, give your answer to 3 decimal places. So fulfilling the demand of the question will give us full marks,
So we need
even
to
though our answer is correct.
so we need to look at every single part of the question and answer it fully.
Yes. If the question says state, then there is no requirement. This is a relaxed question and you may opt any method just to achieve correct answer.
Okay.
That is again demand of question. So y by 25 is equals to known 12 by 24. So y is equals to 12 by 24 into 25. 1 times 2 times 25 by 2 is 12.5. No units, so we leave it as it is.
Okay.
For x again, x by 15 is equals to known pair 12 by 24.
Can I get another pen quickly? Because
Sure,
I'm kind of like running out like the
sure,
ink.
sure, 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 bring it.
Okay, sorry, thank you.
Okay, now we are introducing a new topic, area of similar shapes. So far, we've been dealing with lengths and sides. Now we are going to deal with area of similar shapes. Firstly, whenever it is in exam, we will have to see if the shapes are similar or not. Both have different methods, both are easy. like these question stated that they are similar, so we don't have to worry about that. We just see the pairs. And in exam, if the question says find the area, but it is not given that it is similar or not. It says find the area, not given that it is similar or not. But here it is given that it is similar. So it is being shortlisted that where does it fall? Now, if you see, even if it is not given, I do have all the sides, 5 and 4. So I can say 1 by 2 base into height. 5 4 times is 20, 20 by 2 is 10. On the other side, 10 into 8 is 80, 80 by 2 is 40, right? 1 by 2 base into height. So we do have all the sides. So what is this for that they are similar? So definitely in exam and during this practice questions, some of the sides would be missing. Sides would be missing and we'll use the smaller triangle to find the area of the larger triangle or vice versa. Now let me show you what is the difference of knowing that they are similar and how do we find area of similar shapes. Area of similar shapes. I'll start off with rectangles and squares. Now assume that we have this square. For it to be similar, and I will start with non-decimal numbers. Let me say I'm drawing a new square, which is 2 times the original one. So would that mean if this side is x, new side would be 2x?
Yes.
And if this side is x, new side would be 2x. So just see without calculation, may I say the area is 4 times the original one? I doubled the side, but I can see the area is 4 times. Now doing it with the rectangle, this will create much more clarity. And let me write values as well this time. Let's say this is 1 centimeter and this is 2 centimeter. Now what do? I am doubling the size, keeping them similar. So 1 actually becomes 2 on this side and 2 actually becomes 4 on the other side. So this is now 2 and this is now 4. Does it make sense? Ratio keeps same. So if I just complete the figure without solving, can I see this is 4 times the area of the original one?
Yes, because there's 4 boxes different.
So I'm writing that length when it doubles, area is times 4. When length doubles, area is 4. Now see what happens. I'm going to do it 3 times. Length 3 times. So 2 centimeters, I'm making it 3 centimeter on this side. That was 4. And I'm making it 6 on this side. Now this full length is 6. This full length is 3. Compare it with the original one, the one in red. So if I draw those same triangles, can I see that increasing it 3 times actually increases the area 9 times?
Oh, so it's kind of like square numbers. So if it's 3, then it's going to be 9. If it's 2,
Very good. Very good. So
if it's
this is the relation. Area of first figure over area of second figure is equals to length of first over length of second whole squared.
yeah. So with the 2
Some
and
people understand it better this way. A1 by A2, L1 by L2. I've used it all my life. And some students understand it this way. Area of smaller divided by area of larger is equals to length of smaller divided by length of larger. Both are completely acceptable.
Okay.
So those triangles, values were given, but definitely when we solve for exam, some of the values would be missing. And it was like this, 4, 5, and we know area is equals to 1 by 2 into base into height, that's 10. And another one was given. Let me draw a nice shape. This is 8 and 10, and we know that this will be 1 by 2 into base into height is 40. Let's say these are centimeters, so centimeter square. Now just observe, length is being doubled. What happens to area?
Times 4.
Thanks. So what would be the case? Let's say that this side is missing. I'm not finding those sides, but it is only given that it is twice the length of that. It is twice in length. So I would say area of 1 over area of 2 is equals to length 1 over length 2 whole squared. So this goes the same way which we were doing in lengths, that we keep in numerator the larger one and at all times we do that same. So for example, I keep this area which is 10 divided by the unknown area. On the other side, I use one of the side which is 4, and it is already given that it is double of that. So I can write 8 whole squared. I'm just plugging in the missing values. Any confusion till now?
No.
Now we work out. This is 8 over area of second triangle, and working this out makes it 1 by 2 whole squared. Next step, 10 by second area is 1 by 4, cross multiply. 10 into 4 is 40, and on the other side, 8, 2. So this is how we solve for areas. Now see, these two triangles are similar. So end of debate. They are similar. It is already given. So what is the ratio of the smaller area to larger area? See, area of smaller divided by area of larger is equals to length of smaller divided by length of larger whole squared. So area of small, length of smaller is 18 and length of larger is 21 whole squared. On the other side, now this time both the areas are unknown. So using calculator, 18 by 21 whole square, I'm getting 36 by 49. So ratio is 36 ratio 49. If I could just simplify as well, this is 3 6 times, 3 7 times. 6 square is 36, 7 square is 49.
Why did they say area if we can't find the area?
We're not finding the area. We're just telling the ratio.
Oh, but isn't it times like, oh wait, yeah, we did square it. So yeah.
Yeah. Now assume that how many playgrounds do you have at school?
2, 3.
3 playgrounds. A, B, C. Now just let it be in order, starting with the smallest one. So if I say the smallest one is 1 unit, what is the second and third one comparable compared to this? Is it the same size or bigger? How much bigger?
Well, the first one, A and B, are kind of the same.
Kind of same. So 1 ratio 1.
And then C is a bit larger, so maybe 2.
Maybe 2. Now see, area of first ground, area of second ground, and area of third ground. First two are similar. Just to make the discussion easier, I'm eliminating this. Now we are talking about these two grounds, second and third one. So it is almost the double of the first one. Did we say that this is how much? 10,000 meters square, 10,000 feet square. So areas are known. These are the ratios. For
One.
example, I talk about a carpet piece in one room and a piece of carpet in another room. And I just say that that is double in area, but I never mentioned any size or area. That is just the ratio. One may say that we have two houses and the second one is 3 times the area of the first one.
That's
But
just a
he or she never mentioned the area. It may be one canal to 3 canals. It may be 10 marlas to 30 marlas. I hope you understand those units.
no.
Okay, we'll talk in meter square or feet square. So, and if I say that the sports teacher just let me know that this was 3 acre. So the second would be 6 acres. So when both of these are unknown, answer is in ratio. When one is known, we can find the other unknown and give the exact numerical value. Worked example 10. Similar rectangles A, B, C, D, and M and OP have lengths 3, 5. It is given the shape is rectangle, whatever the shape is. They are similar, okay. And we know the ratio 3, 5, yes. If rectangle ABCD has area 900. Now let me say this is 1 and second. Because I can see that this is 3:5, I can say this is smaller, this is larger. Any issue
No.
in smaller? So just plugging in the values, area smaller, area larger is equals to length of smaller, length of larger, whole squared. Now, whatever data I get, I'm going to plug that in. So ABCD is smaller and area is 900. Area of larger is unknown. Side of smaller is 3. Side of larger is 5. Now, there's nothing given. It is 3 centimeters, 3 meters, 3 feet, 3 yards. It could be anything. But whatever it is, they are in ratio of 3, 5. Now, here jumps in the calculator. Over area of larger is equals to 9 by 25. And we cross multiply 900 into 25 by 9 is equals to area of larger. So area of larger is equals to 2500. And because I knew 900 was centimeter square, so I can say this is centimeter square. Clear?
Yes.
Now see the shapes are changing. We started with the rectangles. Now this is a kite shape. And not a perfect kite because SR is somehow smaller than RQ. So let's say a quadrilateral, four-sided figure. So let me hide that. The shapes below are similar, given that area ABCD is 48. And sometimes I like to write it in on the shape. So just like it's confusing going back again and again. The area of PQRS is 108. Find the diagonal AC in ABCD. So we do know that they are similar and we accept it. So areas are given. One of the side is given. We can find the other side. So which formula will you use?
Hmm. For the kite, finding the area of the kite.
Yeah, to find AC. Areas are already known. 48 and 108 are the areas.
So we can just do 1, 0, No, we can just do 48 over 108 equals to
48 over 108 is equals to
18
see,
over,
see that again. 48 is on left hand side.
so it would be the height, so it'd be AC, H is
Unknown AC over
18.
18. This is not it. 48 and 108 are areas, and AC and 18 are length. So that needs to be squared.
So we can do, okay.
So area of smaller divided by area of larger is equals to length of smaller divided by length of larger whole squared. And now see, we have plugged in, and now we can solve it. We can either take square root on both sides or open this square. So 48 by 108 into 18 squared is equals to AC squared. And using calculator, 48 divided by 108 gives me 419 into 18 square gives 144. So AC squared is 144 and then square root both sides. AC is equals to 12 centimeter.
Yeah. Hmm.
12 centimeter long. In each part of the question, the two figures are similar. And this is always relaxing when it is given. We don't have to check for that. The area of one figure is given. Find the area of other figure. So left hand side area is given. Right hand side is unknown. A1 by A2 is equals to L1 by L2 whole squared. Now I'm keeping the unknown at the top, so I have less number of steps. The other known is 187.5 on the other side. When I use that as unknown, side for unknown is 30 and side for known is 20 whole squared. Does it make sense?
So isn't the one under 20 the smaller one?
Yes,
So isn't it A1?
that could be. You can do that. You can do
Also,
that. Let me write it and compare.
shouldn't it be either or?
Yeah, we can do that. We just need to be sure that this is with 30 and this is with 20.
Okay.
187.5 is with 20, is corresponding to 20, and 30 is corresponding to this unknown. So see, if I've written them in front of each other, A1 in front of 30 and 187, which is known, in front of 20. And if you do it other way around, if you wish 187.5, then you'll say that A2 is unknown. But what sides are you going to use? With 187.5, you're going to use 20. And with A2, you're going to use 30. Now, somehow, if you have the unknown in the denominator, you'll have to go through that cross multiplication. So see, A1 stays there, and this is going to be multiplied on the other side, which is 30 by 20 whole squared into 187.5. So 30 by 20 is 3 by 2, squaring is 9 by 4 into 187.5 is, I'm getting the exact answer, 421.875. And just depending on the data, I'm writing it to one decimal place.
The area of the larger one is 421.9.
4 to 1.9. Solve B part. I'll do it here and we'll match our answers. B part.
3.7.
What did you get?
3.7.
You get 3.7. Do you think it is correct?
It doesn't seem right.
So what would have gone wrong? You would have switched those sides. Area of smaller against length of smaller. Quickly, another attempt.
Uh, 78.06.
78.06, that's right. So all we have to do, be careful that you write the corresponding sides in front of each other. Area by area equals length by length. So area of first one is unknown. Area of second is 17. But whatever we choose, first or second, now I know 17 is corresponding to 7. And the unknown is corresponding to 15, and the length needs to be squared. So A1 is equals to 15 by 7 whole square into 17 is equals to 78.06, which is approximately 78.1 meter square. One more quickly, C part.
$1,562.5.
Checking. Please say that again.
1,562.5.
Very good. Second area is 1562.5 meter square. Okay. So whatever we do, we just plug in the values carefully and we'll be good to go. So now you want me to prepare a test from those 10 topics.
Yes. I mean, you can separate it into different sections, like I said, like from 1 to 5.
Yeah,
And then,
uh, okay, 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 got it. For example, like you have to understand this. If I make test for only one chapter, consider this the current one. So what would it be? It would be like 6, 7 questions. So for example, if we are making test for 5 chapters, we may have two questions each, and it would be 10 questions. So we increase the syllabus, number of questions from each chapter would reduce to make it realistic, to make it practical, being possible to solve and make and check and keep the difficulty level of the questions same.
if you can, instead of 2 questions, could you make it around like maybe 4 for each?
I'll do it. Just give me some time. I'll be right on it after I just have 2 more classes
Mhm.
and I'll be on it
Okay, okay.
and share as soon as possible.
Okay, thank you.
You're welcome. Anything you would like to ask?
No, nothing,
Okay.
nothing.
So I'm not sharing any homework. You just take your time, a quick revision maybe, and I'll just prepare and share on the given email.
Okay, thank you.
We did till 1C. So 1D. Area of the second one is missing. Let me label it A2. If I write A2 by A1 is equals to L2 by L1 whole squared, is there any issue? We used to write 1 first, but now I'm writing 2 first.
No.
So we just plug in those values. A2 by 135 is equals to length of second one is 25, length of first one is 15 whole squared. So A2 by 135 is equals to 5 times 5 3 times squared. So A2 is equals to 25 by 9 into 135.
For like when shapes are similar, I remember yesterday we were talking about how the angles have to be the same and also the lengths have to have the same proportions, like their same ratio. So, for example, I think there was a question that you sent me for homework, and it was a triangle, and it was two different triangles, and you were asking me if it was similar or not. And one of the triangles, like one of the shorter sides and one of the longer sides, the shorter side had longer length than the longer side. And then on the second triangle, the longer side had like it was normal, like it was the longer side had more and the shorter side had less. So when I was doing it, I like matched up the shorter side with the shorter side. But I was on a call with my dad yesterday, and he was telling me that it has to be like, for example, the for the lengths, the largest length goes with the second triangle's largest length, and the second largest goes with the second triangle's largest length. So does it have to be in the same parts, like same place of a triangle, or can it just be like largest with largest?
One thing, largest with largest, that is true. Second thing, image may be given straight away or it may
Mhm.
be twisted. I'll draw it to clarify. For example, if I just draw this, and now these are not labeled, but it pretty much gives the image that which side goes with which side. For example, this is 3, 4, and 5, and this is 6, 8, and 10. Now I've written all those sides, nothing is unknown. So we know largest goes with largest, smallest goes with smallest, and definitely we are left with the middle one, which goes with the middle one. These are 3 sides. We may have 5 different sides. We may compare pentagon. So largest with largest, smallest with smallest is a quick method to understand. Now, for example, if sides are missing, let's say one of the new examples, I draw this and we write this is 3, this is 4, this is 5. And now the second one is twisted. So X, Y, and let's say this is 9. Now, what do you think this 9 corresponds to
With the three.
with the 3? Because on the right hand side, that feels like smallest. And on left hand side, 3 is the smallest side. Other than that, we can also say the longest with longest, which is 5 and X. But we can also say 5 is opposite to 90 degree, X is opposite to 90 degrees. So we may find any difference. So if I wish to write, I would write 3 over 9 is equals to 4 over Y. Any objection?
No.
So when solving, I can also see that this is basically 3 times. So Y has to be 12. But we are showing this working. So 3Y is equals to 4 into 9. Y is equals to 4 into 9 by 3. And we get 3 1 times, 3 3 times. So 12. Same
Yeah.
goes with X. If I write X first, I'll have to write 5 in the denominator. On the other side, known sides. And x is equals to 9 by 3 into 5. 3 1 times, 3 3 times, 3 5 times is 15. Now understand this. For example, I'm just holding this and opening up the camera. And I take a picture of the door in front of me, of this bag. Now see, are you able to see that?
Yes.
I was just holding this bag. Now if I hold this bag again on this side, do you see any difference in size? Picture
Yes.
and
One is large.
one is large. So whatever this side is, if I say that this is 5 times smaller, so every length would be 5 times smaller.
The ratio.
One thing.
5 times.
Now, see that again. One thing is longest by longest. Now, if you can see that image. But what happens when I twist this phone? Do you see the handle for the bag is to my right and the handle for on in the mobile is to my left? In this case, that helps very much. Smallest with smallest and largest with largest.
So when it's flipped, then it's easier to just find out like the place where the length would be in, right?
Any difference, small with small or angle opposite to angle. Now observe one more thing. The image has reduced in size, but what about the angles? If this corner was 90, it is still 90. If this was at 120 degrees, it is still at 120 degrees. And on top of that, if I just pinch it and change the sign, angles are not changing, size is changing. So they are proportionate at all times. So yes, smallest by smallest, that is just a quick pick. If I draw this and I say these are parallel, so you would know that there are two triangles. Now, what are we thinking is inside this balloon? We are thinking about these two triangles. To make it easy for us to talk, I'm labeling it A, B, C, D, E. And smaller one is A, B, C. Larger one is A, D, E. Now we know in the smaller one, A is equal to the one in the larger ones, both A. And B for the smaller one is equal to D in the larger one because they are corresponding angles. And C in the smaller one is equal to E in the larger one. Now, if we just ignore the small side with small side, long side with long side, because no length is given. No length is given. We may be confused that AB is larger or AC is larger. They may be isosceles because length is not given. You see,
So
in this question, we were having 3, 4, 5, 6, 8, 10, 9yx. Lengths were given, but here lengths are not given, but still we can answer. Just tell me, if I write BC, what do you think is the corresponding side?
DE.
DE, that's right. Now, what is the reference? This angle marked in red is opposite to BC in smaller, and the same angle is opposite to DE in the larger. I'll do it again with different sides. Now, if I select this angle, opposite to this angle, there is AC. And same angle opposite to that is AE. Do you agree?
Yes.
And with the third one, this
AB
double
and
tick,
A.
AB and AD. So we just need to know which sides are corresponding to each other. And then we just plug in the values.
So which side looks right with the clues given in the shape, basically?
Yes.
Two. Okay.
And we have few cases because I wanted you to think over it. So I didn't make it easy yesterday. one case is right in front of you. This will be always 100% same anytime, whatever the values are. I'll quickly draw it again. Now see, this over this. Second, this over this. Third, this over this. Always the same. We just did it with angles. Second case. This was case one. And second case is the butterfly triangles. So these two are parallel. Now, this side is always corresponding to this. Now, observe that in case one, left side was equal to left, but in case two, left is equal to right side. I'll show you how. And this one in red is equal to this one. So they're twisted. How are they twisted? Do we agree that these two angles are same, known as vertically opposite? And opposite to this angle is green side and green side. So the ones in green are corresponding. Now the ones in red. When we talk about the ones in red, this angle is equal to this, named as alternate angles. So
Yes,
in
because
front of same angles, that is why they are on opposite sides. Whereas in the first case, we had the angles on same side. That is why we had the sides on same side. Now labeled diagram. A, B, C, P, Q. This is always the same. AB over AP is equals to AC over AQ is equals to BC over PQ. Second case. M, N, O, R, S. So MN over RS is equals to MO over which side do you think?
with RS, I mean
M
OR.
with MO is OS. See, MO is on this side and OS is on the other side. Why are they on the other side? Because the angles are also on the other side, alternate angles. Last one, NO is corresponding to
It will be with OR.
OR because NO is front of this angle M and the alternate angle is S. So opposite to these angles is NO and OR. So these are the
Okay.
two cases. The third case is the one which we already discussed, two separate triangles. We'll slowly move towards one triangle. This would look like this. These lines are not parallel, but we may be able to show how are they similar. So we'll slowly move towards this. I hope your question is answered.
Yes.
Question number 2. In each part of this question, the areas of the two similar figures are given. Find the length of the side marked X in each. Before we do this, I had one thing in mind. Remember, we discussed that suppose our house is like this. And let's say the dimensions were 35 feet by 65 feet. You understand what feet is? 1 feet is equals to 12 inches. So this is 35 feet by 65 feet. So if someone says that my house is double the front you have and double the back you have. So they're basically saying they have 65 and 65 this way, and they have 35 and 35 this way. Basically, he's telling you that he has 70 by 135. 130. 65 times 2 is 130. So without calculation, we would know that the area is 4 times. This
We
is
talked about with like square numbers. 2 with 4, 3 with 9.
yes. This is 10 marlas, so that would be 10 into 4, 40 marlas. Now one more thing. We are walking in a street, and let's say this is the street. A person walks from position A towards position B, and he is admiring how beautiful these houses are. All these lines, this is the first house, then the second house, then the third house. Now assume that he notices that the front of this house is 35. Front of this house is 35. And then he notices that there is another house whose front is 70. In
So
this
double.
case, the area may not be 4 times. Why so? Because all of these houses are of equal length and backwards, because on the other side there's another street.
Oh, so if only one of the sides are double and the others remain same, then it's not going to be times 4.
No, and then we say they are not similar either. So this would be another street on the other side. So the boundary is touching on the back, and obviously the house is built inside this area. Only the boundaries are touching. So maybe this person has bought 2 adjacent plots. So in that case, we know, yes, they are not similar. So if this is 10 marlas, this would be 20 marlas, because the front is double and the depth is same. And why are they not similar? Because every length is not in proportion. Although 35
Only
doubles, but this 65 is not changing. Okay. So question number 2 says, in each part of this question, the area of the two similar figures are given. Find the length of the sides. So what we were doing, we had those lengths and we were finding the areas. Now area is given and length is missing. So let's start with question 2A, which
so it'd be
says,
3, yeah.
sure, go on, go on.
So it'd be 333 over 592 equals to
Let's write,
x
let me just
over
write the formula once. Yeah. So 333 by 592, and on the other side,
x over 32 squared.
x over 32 whole
Squared.
square. Now it is our choice. We make the square on this side or we take square root on the other side. Because we may get answer in perfect integer or we may get
I think we should
decimal
keep
answer.
the square root of 32, but just put the square on top of the x.
Both way it is
And
correct.
then afterward,
333 by 592 is equals to x square by 32 squared is 1024. And 333 by 592 into 1024 is equals to x square. 333 by 592 into 1024 gives me 576. So x square is equals to 576 and x is equals to square root both sides. Square root of answer, I'm getting 24. One way is
the
this, and the other could have been triple 3 by 592 is equals to x by 32 whole square. And this is entirely personal preference. So I'm taking square root of triple 3 by 592 and it gives me 3 by 4. So 3 by 4 equals x by 32. So 3 into 32 by 4 is equals to x. And x is equals to 32 divided by 4 is 8. 8 into 3 is 24 centimeters. Because not all the time, it won't be integer all the time. We may have decimals as well.
Like with
Try
this question, like
to B. Sorry, what did you say?
I was saying like with B where there's decimals.
Yes. Try B part. What did you do?
29.8.
29.8. I think I'm getting exact 30.
Oh,
Let's see.
exactly.
Let's see. Whenever there are decimals, we are using calculator. So we will just keep it as it is. So we know A1 is 272.25. A2 is 900. And we know length 1 is 16.5 and length 2 is x. So A2 by A1 is equals to L2 by L1 whole squared. Area 2 is 900, whereas this is 272.25 is equals to length 2 is unknown and length 1 is 16.5 whole squared. Now do it this way. Square both sides. Just keep it as it is. 900 by 272.25 square root. On the other side, it is x by 16.5. So we multiply this. X is equals to 16.5 into square root 900 by 272.25. Now punch this as whole in calculator. This would avoid decimals.
I still got the like the decimal number, so I'm gonna redo it.
Basically, when you are doing the square root, you get 20 by 11. And if you go in decimal, you get 1.818. That is recurring.
Mm-hmm.
So if I just may represent it with the dot, this is the number. Make sure your calculator is not fixed on two decimal places.
Yeah, 30. It shows me 30 as well.
Yeah, did you get it?
It shows me 30 as well.
Yeah, 30. Very good. Okay. I'm moving to question number 3 as C and D parts are of the same nature. Clarissa is making a pattern using a cut out rectangular pentagon. How will the area of the pentagon be affected if she doubles the length of sides?
Well, the area will be multiplied by 4.
That's right. Because doubling it is 2 squared. So 4 times. If she triples the length,
Does that mean like triples it? Like times, so it's gonna be times 9?
times time. So 9 times. Halves the length.
1/4, so it's gonna be 1/4.
Very good. Decreases 4 times. Question number 4. If the areas of two similar quadrilaterals are in ratio 64:9, what is the ratio of the matching sides?
Oh, so we just square root that. So it's gonna be 8/3.
That is correct. And if we have to show the working, sometimes the examiner says show the working. So again, we use the same formula, A1 by 2 equals L1 by L2 whole square. And this was 64 and 9. On the other side, both the sides are unknown. And yes, square root sides. So you get 8 by 3. So 8 ratio 3. Okay, now we are moving from two-dimensional shapes to three-dimensional shapes. So if you can see this diagram in front of you, just imagine that these were two boxes in horizontal direction. Now 2 to 4. And in vertical direction, again 2, again 4. And when we move backwards, that is the depth from 2 to 4. So basically what's happening, every length is being doubled. And doubling every length increases the volume 8 times. See the diagram in front of you. Just imagine that we have this one cube. I'm changing the color. So if I just double every length, that means height would be doubled, base would be doubled, and so the depth would be doubled. So if I have to fit in the original cubes in it, count them with me. they would be 8 in number. Again, changing color. If I just split it up, this is first. Now there's one at the back and left. So we have 4 at the bottom and 4 on top of these. So just by doubling the length in case of 3D volume, this is moving 8 times. In case of area, doubling was 4 times. In case of volume, it is 8 times. Hence, the formula is V1 by V2 equals L1 by L2 whole cube.
So it just basically cubes everything.
It cubes everything. And so does the case with mass, because we understand that volume and mass are three-dimensional quantities. And area is two-dimensional quantity, length is one-dimensional. Okay. The cones shown in the diagram are mathematically similar. If the cone has a volume of 40 centimeter cube, find the volume of the larger cone. So smaller cone is 40 cm cube, larger is x cm cube. Now we use the same formula, V1 by V2 equals L1 by L2 whole cube. You can use length for height and radius and anything.
So
So
it'd
that
be
is,
x over 40 equals to 12 over 3 cubed.
that's right. Two five six zero centimeter cube.
Two, five, six, zero. And x equals to, yeah, 2560.
Two shapes are shown in the diagram, are mathematically similar. If the area of the larger shape is 216 and the area of the smaller shape is 24, find the length x in the diagram. So again, that is the previous topic. So let's quickly do it. And this is 216. This is 24.
So 216 over 24 equals to x over 12 cubed.
X over 12 squared. These are in
Oh, because yeah, so it's
216 by
square.
24. 216 by 24 gives me 9. So square root both sides give me 3 is equals to x by 12. 3 into 12 is 36. 6 is equals to 36. Centimeter. Question at the bottom. A shipping crate has a volume of 2000 centimeter cube. If the dimensions of the crate are doubled, what is the new volume? Dimensions are doubled. So what do you expect?
16,000.
8 2 times yes. So when they are doubled, it increases by cube relation. So 2000 into 8 is 16,000. That's right. The two cuboids A and B are similar. The larger has surface area 608. What is the surface area of smaller? A1 by A2 equals L1 by L2 whole squared. Now let us keep the unknown first. Over known is 608. Unknown's side is 5. Known's side is 8 whole squared. So A1 equals 5 by 8 whole squared times 608.
Mm,
Do we have the same answer?
I'm quickly redoing it. Yes.
So 237.5 centimeters squared. Practice exercise. Copy and complete this statement. When the dimensions of the solid are multiplied by k, the surface area is multiplied by.
K cubed.
Think again.
Surface area. So K squared
Basically, when it's area, so k squared, and volume,
is going to be K. Oh no, K cubed.
k cubed. Yes. Second question. Two similar cubes A and B have sides 20 and 5 respectively. What is the scale factor of A to B? Scale factor of A to B
4. 1 over divided by 4.
divided by 4. So you say it 1 by 4 or 0.25. So basically scale factor is 1 by 4 because it's reducing in size. What is the ratio of their surface areas?
It's going to be 1 by 8.
No. See this. If I say
1
this
by
is A, if I say this is A and this is B, sides are 20 and 5. Do you agree? If I just simplify them, may I write 1 and 4? And what are these? Length or area?
it's the lengths.
These are the lengths. So may I write 1, 4 as ratio of lengths? Now he's asking about the surface areas. So we know we have to make a square from length to area is squared. From area to length is square root. So when I move to area, this will be 16 ratio 1.
Ooh. So it's going to be 1 over 16.
So this question 2 never says that from A to B or B to A. So we just write 16 ratio 1. That is understood that 16 is for the larger one. C part. What is the ratio of their volumes?
64 over 1?
Very good.
60.
64 ratio 1. Because you knew the lengths were 1 ratio 4. So for volume, you did the cube. Question number 3. Pyramid A and pyramid B are similar. Find the surface area of pyramid A.
360.
Mm,
Oh no, not 360. 216.
216, yes. Question 4. U has two similar cylindrical metal rods. The smaller rod has a diameter of 4, the surface area of 110. So basically we have length and area both. The larger rod has diameter 5. Find the surface area. So first pair is 4 and 110. Next pair is 5 and x.
172, if I round it up.
Just a minute. 5 divided by 4 squared times 110 is, yes, 171.875, which is 172 or 171.9. That would depend on the accuracy of answer asked. That's correct. Question number 5. Cuboid x and cuboid y are similar. The scale factor x to y is 3 by 4. So if I may see that from x to y is 3 by 4. That means y is actually smaller in size.
Mhm.
So if I write 3 and 4, would that be fair?
Yes, because y is smaller.
Y is smaller. Because when we had 20 and 5, this was reducing by 4. So 1 by 4, so basically this was 1 and this was 4. Smaller one over larger. So smaller, larger. So I can say I have ratios of lengths which are 4:3 because of this 3, 4. X corresponds to the larger one, Y corresponds to the smaller one. So if a linear measure in cuboid X is 12 millimeters, what is the length of the corresponding measure on Y? Using the same ratios, may I write here 12 and X? I should use some other symbol. X is already displayed. Unknown P. So we can cross multiply. 4P equals 3 into 12. P equals 3 into 12 by 4. 4 1 times, 4 3 times, 3 3 times is 9. So 12 millimeters on X corresponds to 9 millimeters on Y. Try B part.
49.95. So if we round up,
We'll keep it as it is because it is exact answer and just two decimal places. C part. If cuboid X has volume 35.1, what is the volume of cuboid Y? V1 by V2 equals L1 by L2, and what will be the power?
Cubed.
Cubed.
So 14.8.
35.1, and length of Y was 3. This was 4. Cube Y is equals to 3 by 4. How are you doing so fast?
Calculator. That's fine.
Hey, you're not writing it.
But I'm writing it in my brain.
Okay,
I'm
okay.
using
So as you're getting them correct here, do it correct in the test as well. It's 14.8, yes. Centimeter cube. For each of the part of the question, the solids are similar. Find the unknown volumes. Okay.
.8.
20.8. B part.
94.8.
94. I think I made a mistake. I'm getting 21. Let me recheck quickly. 4 by 3 cube is equals to unknown by 9. 4 divided by 3 cube times 9. I'm still getting 21.
Oh, I know what I did wrong. Besides that, I had another equation and I accidentally times it by 40 instead of 9. So yeah, 21.3.
21.3, yes. C part.
0.75, yeah.
Correct. D part.
56.6.
Correct. Question number 7 says find the unknown quantity for each of the following pair of similar shapes. Okay, so previously all the volumes were missing. Now whatever is missing, we have to see that. So in question A, both of the lengths are there. One of the area is missing. Area over known area is equals to side of the larger one over side of smaller one. Whole squared is equals to 15 by 3 whole square into 21.
525. 525.
Again getting a different answer.
Okay.
Mm, yeah, I got my mistake. I cubed it actually.
Oh,
So 525, yes. 525 centimeters square. B part, volume is missing.
six 6,816. Yep.
That's correct. C part, radius is missing. That means the length.
$36. Yep.
Correct. D part, side is missing.
Fourteen point two. 14.15, 14.2.
Yeah, 14.2. Okay, applying your skills. Karen has this set of 3 Russian dolls. The largest doll is 13 centimeters tall. The next one is 2 centimeters shorter, and the third one is 4 centimeters shorter. Draw up a table to compare the surface area and volume of the dolls in algebraic terms. So if I start with the largest one, then middle, and then the smallest one. So we know Karen has this set of Russian dolls. The largest doll is 13 centimeters tall. The next one is 2 centimeters shorter, would mean 11. And the third one is 4 centimeters shorter.
Is
So
that from
that
13?
gives,
Oh,
yep, because he took the largest one as reference. So drop the table to compare the surface area and volume of the three dolls. So we know these are the lengths. For area, what will we do?
well, because it's going down by 2, so it's supposed to be
Yep.
uh
No, no,
divide.
don't think about two. We actually have those lengths. We have those lengths. You getting it? Length is basically square of area,
Mhm.
and volume is cube.
Oh,
Uh, area is square of length, and volume is cube of length.
oh, so it's going to be 13 times 13 squared basically,
Yeah.
right?
Yes.
So first one is 169, second one is 121, and third one is 81.
81. And for volumes, we do the cube.
So first one is 2,197. Second one is 1,331, and third one is 729.
29. And now to see the second requirement, it says draw up a table to compare the surface area volume of the three dolls in algebraic terms. So if I say largest, medium, and smallest, if I say largest was x, so medium would be x minus 2 and the smallest would be x minus 4. Now for the areas, what we do is x square, x minus 2 whole square, x minus 4 whole square. And for the volume is x cube, x minus 2 whole cube, and x minus 4 whole cube. Question number 9. A manufacturer is making pairs of paperweight from metal cones that have been cut along a plane parallel to the base. The diagram shows a pair of these weights. If the volume of the larger uncut cone is 128, find the volume of the smaller cone cut from the top is 42. Find the length of x.
So the small cut part is 42.
Small cut part is 42.
Okay.
This one right here is 42. This complete is 128. And we need to find that x. Thinking.
Should we first find the like the cut part of 12, like the
Very, very good. So we will first go with this 42 and find this height. Let us name that y. So we know we are dealing with volume. V1 by V2 equals L1 by L2 whole cube. 42 by 128 is equals to y over 12 cube. So I'm working out for y. 42 divided by 128 into 12 cube, and cube root answer. This gives me 8.276. I'm writing 8.3.
7. 8.3. Yeah,
Yes.
3.7. So x is 3.7.
X is 3.7. Okay, now this is a touch of different topic. We've been talking about it without the questions. Difference between similarity and congruence. So what we did so far with similarity is all the angles are same. The sizes are in ratios, proportion. The only difference with congruence is all the angles are same and all the sides are also same. So
So
no,
basically they're exactly the same shape.
exactly the same shape, exactly the same size. So when we were talking about this bag and the picture, they were similar and not congruent. So if I have two same bags, they will be congruent. So you see these shapes, all the angles are same and all the lengths are same. For example, when we were talking about this is 3, 4, and 5, and this is 6, 8, and 10. So these two were similar.
Not
So
congruent.
not congruent. So this is 3, 4, and 5, and I have another one which is 3, 4, and 5. Now these two are congruent. All angles same, all sides same, congruent. You could also imagine that when you place one shape over the other, the one which is below would be hidden because they are exactly the same size. You won't be able to see it. So if two shapes are congruent, what can we say? Corresponding sides and lengths are equal. Corresponding sides and lengths are equal. Angles are equal. Shape have same area. So when everything is same, obviously they'll have same area and they'll have same volume. For example, two new cars of same model. So they are congruent. Every length is same, every angle is same, weight is same, volume is same.
Right.
Exercise 11.7. These two figures are congruent. It is already given, so we are not thinking about that. They are congruent. So it has to be equal in all manners. Now, which side is equal to AB?
MS.
MS, correct. Which side is similar to EF,
PQ.
PQ, and MN,
BC.
BC, correct. Okay. Which angle corresponds to BAG? I'm going back. BAG.
MSR.
MSR. MSR. Okay, second one is PQR.
EFG.
EFG, right. Third one is DEF.
OPQ.
Right. Write the congruency statement for the two figures. Okay, now,
Well,
yeah, sure.
all the lengths are equal and all the angles are equal, so they're congruent.
Yes, so they are congruent. We have to name the vertices. When you make congruency statement, you name the shape so that the corresponding vertices are in same order. Now see, when you said that GAB, can you say, find that again, GAB?
Yes.
GAB is congruent to which angle?
RSM.
Okay, RSM. If someone says MSR, what would you say?
It's still correct because it's still the S.
It is still the S. The angle is correct, but the order is not. See, you name the shape so that the corresponding vertices are in same order. Why so? When we talked about GA and then B, look at this. GA smaller side, B longer side. So smaller to longer. And when you said RSM, you said smaller to longer. You kept the correct order. I was waiting that if you would make any mistake, but all of these were correct. So just to discuss this, I brought this up. MSR, they have to be in order. You start with the smallest and you end at the longest, or anywhere around, but they have to be the same. So if I just start with ABC on this side, so A, B, C, D, E, F, G. I've wrote this for one image, and A, B, C, that would be SMN. Do you agree?
Yes.
So we start with S, S, M, N, O, P, Q, R. So we'll state that A, B, C, D, F, G is congruent to S, M, N, O, P, Q, R.
So we just have to write that?
Yes. And we'll say that angles are same. So basically now what we can say is these coordinates are magic for us. Without looking at the diagram, I can say AB is similar to SM. Now just look at the diagram. Is it so?
Yes.
Now without looking at the diagram, I can say DEF angle is similar to OPQ angle. Now see, is it so? Because we wrote the corresponding vertices. So first two correspond to first two, second two, third two. Everything will correspond to each other because we wrote in the corresponding vertices in order. Whatever angle is at B will be equal to angle at M. Whatever angle is at G will equal to angle at R.
Because we wrote them in order.
Yes. So one thing is we rewrite these vertices. Second is either we state that all the angles are same, or we state that these sides are of same length. Which of the shapes in the boxes are congruent to each shape given below? Measure sides and angles if you need to. So let us just talk about A first.
I,
This small a is similar to I. Next,
A,
capital A,
C,
C.
and that's it.
That's it. So about B.
F, D.
Okay, now look at this. This may seem like a rectangle.
Mhm.
It says measure sides and angles if you need to. Do you think this side is equal to this side? It feels a little
It's
longer or
like
shorter.
large.
It seems a little small. So I'm ignoring these. These are not congruent because the one in question is larger in size and F and D is smaller in size. Just look at this K. This is still a
No.
rectangle, but not equal in size. So we are just skipping this. And for now, we put a question mark on these. And so would be the case with this A. This is actually smaller. So
Only I think I.
obviously, when we have this on page, we'll be able to measure it. So look at C.
would B still be like too small in G?
It feels smaller. So we know that these are the shapes. And now if you just look at J, C somehow looks like equilateral, but
And J
J
does not.
is definitely not equilateral. And so where are we lacking now? We identified the shape. The angles may be same. B, G, and the question C all are equilateral, but we need to confirm the length of the side. And for the D part, we
E,
have E and H
not
and
L.
L. And we need to see maybe I looks like a rhombus and not a square. So definitely we'll measure the sides and angles when we do it on paper. Question 3. For each set of shapes, state whether the shape are congruent or similar. Okay, this is nice. So A part, is it congruent or similar?
Similar.
So similar.
Uh, but is ABC, I mean,
Yeah. Yeah, we'll
ABC and are they both like congruent?
okay. Are these two similar or congruent?
I think they're congruent.
They're congruent, and in reality, how will we do it? We'll measure the angle and sides. And are these two?
No, similar.
So they're similar. So for each set, state whether any shape are congruent or similar. Okay. So when we look at B, are these two?
No, they're similar.
They're similar. What about these two?
Similar.
A,
Not
R.
even similar.
Say that
Not
again.
even not
Uh,
even similar. Not even
So,
congruent or similar.
so it's not similar and not congruent. C. What about these two?
Congruent.
I just think, yeah. So they're congruent. And these two?
Not similar, not congruent.
Very good. Not similar, not congruent. D part. These two?
Congruent.
Congruent. These two?
Similar.
Similar. These two?
Similar.
Similar. Last part. Okay, these two
Similar.
seem like similar, yes. And these two,
Congruent.
they look like congruent, and we'll make it sure by measuring them. So AB should equal PQ, smallest with smallest, and AC should equal PR, longest with longest. And third side is obviously left for comparison basis. One more question for today. Figure ABCDEF has AB is equal to BC. So let me mark them. AB is equal to BC is equal to CD is equal to DE. Redraw the figure and show how you could split it into two congruent shapes.
You can cut it through the middle from E to C diagonal. F to C diagonal.
F to C. So F to C. Very nice. B part. Three congruent shapes.
From the half of A and F, a line through like C, and
Okay.
then
Okay.
also from the half of F to E, a line through
Basically, CD
yeah.
extended and BC extended. So BC extended and CD extended. Third one. Four congruent shapes. That is a bit rough. Hmm. I'm thinking as well.
I think I had a similar question in one of my math competitions, but I can't remember it. I
I'm
think
feeling
okay.
that too. I've seen it somewhere as well.
I'm thinking triangles, but it would be too much.
Yeah, I thought so. There were six. When I was cutting through, there are six. So four congruent shapes. If we think about trapeziums, the way, this way, no. I think you just copy this shape or take a screenshot. Let me zoom in and do practice for this C part.
Only for the four congruent, right? Well, we
Yeah,
already know the other.
you've already done those, correct?
Okay.
So when are you planning to attempt that test?
Today.
I hope you get all of them correct.
Hopefully.
Few of the questions are hard. Don't rush through them. And few of the topics are having this the nature that the questions cannot get hard, like
What's the
the
time limit?
that's infections.
Is there
Actually,
like a time?
I didn't calculate it. Whenever you prepare your test, I do a mental math with those questions and see that what is the suitable time. So you can do like just record the time
Okay.
that how long you took. If you feel the test is longer, you may split up into sections for yourself that you did the first five in these much minutes and second five in these minutes. Then we'll add them up. Like you can take your break and make a stopwatch or something.
I think there's like 162 questions, right?
116 something marks.
Yeah. So
Like if
there's
you're
around.
counting those parts, the you'll take like 5 to 10 seconds for few of the parts, like in the first 4 or 5 sections. Just like the exercise we did for gradient and y-intercept.
Oh, so it's just finding the. Okay.
Yeah.
Okay.
So I'll wait for your test and inshallah we'll meet in next class.
Okay. Oh, and also, so are you gonna send like this picture is the only homework I have, or are you going to send more for like the one we did today?
If you're doing your test, so you need to focus on that. Other than that, we've like done each and every question, and specifically this topic is not that much. So I'll share something to practice,
Okay.
and I'll make those questions that you'll have to use calculator. You won't be able to do them mentally, so
So
you
it's gonna
don't
be a
rush
bit.
through them.
Okay.
Okay, a bit trickier questions
Okay.
for similarity and congruency. I'll share it max by tomorrow. Actually,
Okay.
CIs are going on, and this May June examination. So I'm having a
Mm.
l- almost every class is being doubled for exams. Last exam is on 15th. Today is 12th.
Oh.
So